We will compare the casting techniques, the casting processes with other manufacturing processes. So we have the basic question: why do we prefer casting techniques over the other manufacturing processes? We have several reasons due to which we prefer casting techniques, the casting processes, over the other manufacturing processes. Number one, when the part or the product to be manufactured has large internal cavity, then we will prefer the casting process, the casting techniques for its manufacturing. Examples include the industrial parts.
We prefer casting to manufacture these parts with large internal cavity or cavities to avoid the wastage of material.
Then, when the part or the product to be manufactured has complex internal cavities, then we will prefer the casting for the manufacturing of this part because the other available manufacturing processes, they cannot be used to fabricate these complex internal cavities. The example is the carburetor of the automobiles. Then, when the part or the product to be manufactured has large size and huge weight, then we will prefer the casting for its manufacturing. For example, the structures of machine tools like the bed of lathe machine, the column of the milling machine, the column of the drilling machines, all these structures of the machine tools are manufactured with the help of casting processes because these are the parts or the products with the large size and heavy weight, and they are difficult to manufacture with the help of other available techniques, the manufacturing processes. Then, why do we prefer casting techniques over the other manufacturing processes? When the part or the product to be manufactured has complex shape, the outer shape of the part or the product is too much complex, and with the help of other available manufacturing processes, it is too much difficult or impossible to manufacture to fabricate these shapes. For example, the engine block. Then, when the part or the product is manufactured from a material which is not easily machinable, and because the material is too much hard, it's not easily machinable, then definitely we will prefer the use of casting processes where the metals, the alloys, they are melted into molten form and they are poured into the mold cavities to manufacture the parts or the products. For example, the stainless steel, the titanium, these are the materials, these are the metals which are difficult to machine. The titanium is used in the manufacturing of some of the parts of the fighter jets. Then, why do we prefer casting techniques over the other manufacturing processes? When the reproduction of details are required in the manufactured part or the product. For example, if we want to manufacture a part or the product and it has very minute details, very smaller details, which are very much difficult to be manufactured, to be fabricated with the help of other available manufacturing techniques. then definitely our preference will move towards the casting. Examples include dinky toys, and these dinky toys they include a lot of little details, and the fabrication of these smaller details into the final part of the product is known as the reproduction of details. For example, the manufacturing of statues.
because small features are also included into the statues.
Then we prefer the casting techniques over the other manufacturing processes when the part or the product is manufactured from costly metals. The metals used for the manufacturing of parts or the products they are too much costly, and we cannot afford the wastage of these metals. For example, gold and silver. So in the manufacturing of jewelry, we use the casting process, the investment casting process.
The last reason to select the casting techniques to manufacture the parts or the products is that if we want to manufacture the parts or the products with the minimum directional properties means some of the materials they inherently have anisotropic behavior, means their mechanical properties, their other properties change with the directions. The material have different properties in x-axis, in y-axis, and in z-axis. And also, the anisotropic properties are included into the materials because of the use of the processing operations. For example, the bulk deformation processes, for example, the forging and rolling, also produce the directionalities into the materials, into the fabricated parts or the products. So if we want to minimize these directional properties and want to manufacture the parts with isotropic behavior, means their mechanical and other properties do not change with the directions, then we have to prefer the casting techniques.